Hello and welcome to my channel. I have created this course to help new programmers learn to program in TypeScript. As you probably know, TypeScript is a language very common in web development. Most projects nowadays are using TypeScript for building new software, new web applications, and new services. So I've decided to create this course as a introductory course for new programmers in order to help them proceed. This course will assume that you know a bit of JavaScript, that you understand a bit of programming, although I will be trying to explain everything, but it's not for the complete beginner, to be honest. This course assumes that you have programmed a bit in any programming language, preferably in JavaScript. But I will do my best to make everything understandable, and I will explain every step I'm going to use. So what is TypeScript? TypeScript is a superset of JavaScript that adds syntax for types. It allows for building complex software in a better way because of its support for abstract data types. It saves the developer a lot of headaches because it makes it harder to introduce bugs into the application via tighter integration with the editor that you're going to use. Most probably it is VS Code, but other editors also have support for TypeScript. So the editor will help you find these bugs. You can also write pure JavaScript if you want to. So sometimes there are moments when you just want to write pure JavaScript without going into more complex details. So you can do that as well because JavaScript is TypeScript. In order to install TypeScript, you can do this in many different ways. One of the ways is via npm. If you have Node.js from nodejs.org, you can run the command npm install TypeScript --save dev. The preferred way for this course is via Dino. Dino is another runtime for TypeScript and JavaScript, and you can build full stack applications using it. So we will be using it instead because you will not need to initialize Dino for any new project you want to create. You just create a folder for that and you start coding. While for an npm based project, you will have to initialize your project every time, and you will have to install TypeScript every time. For Dino, you don't need to do that because the TypeScript is supported out of the box. So we will go for that. If you are on Mac, Linux, or Windows subsystem for Linux, then you will have to copy that code for these platforms and to execute it in your terminal. Otherwise, if you are on Windows, then you will need to copy the code for PowerShell and to execute it. And this is the only setup step that you will have to do for both for any of these platforms. So this is the only setup procedure that you will have to do ever for this course. As for editor integration, we will be using VS Code because TypeScript is supported by default. If you produce an error, then the editor will issue an error message or a warning, depending on the severity. For example, if you write this code into your editor and you define a variable called x, which is of type string, you assign a value to that variable, and then you change the value of that variable from a string to a number, then your editor will issue you an error. You will see a warning message, which means that the compiler doesn't accept your code. To achieve best results, I highly encourage you to pause the video whenever you see a code example like this and to type down the code into your editor yourself, because this will train your muscle memory. This will allow you to remember your coding practices, and this will allow you to discover the features of the code as you type it. So whenever you see a code example like this, just pause the video and write it down, or wait until I explain it, and after that pause the video and type it down into your VS Code yourself. As you can see here, this is directly from my VS Code session. So I have declared a variable called x. Actually, it's a constant, it's not a variable. And I've attempted to call a method called callMom. And since the variable or the constant x is of type string and it already is initialized with the value high there, then the TypeScript compiler already noticed that this is a problem. This is an error, and it issued me a message that this function is not declared. I have done something similar. For example, here I have declared a constant y, and I've assigned the value 42 to that, and I've attempted to change that value to 10. Again, the compiler or the TypeScript transpiler issued me an error that y is a read-only constant because it is a constant. You said that it is a constant. Next, I have defined a function called callMom that accepts a parameter called message, which is of type string, and the function callMom is supposed to return a value of type string, and I have returned a result of type boolean, which issued an error again because the return type is string, as I have declared on the first line, but instead of that I'm returning boolean. So this is an error. This is a demonstration of how the TypeScript integration in VS Code will help you a lot to discover bugs. Constants are declared and initialized using the const keyword, while variables are declared using the let keyword. For example, you can declare a constant called a, and you can assign a value 10. Consts are always initialized. You cannot say const a and nothing after that. You need to say what's the constant value of a. Same as for str, const str equals hello. So this is a constant of type string, and it is initialized with the value hello. If you want to declare variables, you can do that using the let keyword. And here you can say, for example, let x without any initialization. TypeScript knows that this is a variable and it will be initialized in the future. Or you can initialize it directly at the time of declaration. For example, you can say let y equals and a string value of ducks. So this is a declaration of y with the initialization process taking its place. Statements are separated by a semicolon. For example, you can say x equals 15, semicolon, x plus equal 3. In TypeScript and in JavaScript, there are two ways to declare functions, using the function keyword and using the arrow syntax. For the first example is using the function keyword. So I have a function do something, which is a function name, and that function receives a parameter called value of type string, and I'm just console logging to the output. So this is a function. Or you can use the arrow syntax, which means you declare a constant name and you assign a function, an anonymous function, to this constant, and that anonymous function looks like this. It receives parameters like this. For example, in this case, it receives a parameter named value of the type string, and it returns void, which means it returns nothing, and it outputs the value to the console. I will be returning to the two functions later on in this course. I will be explaining a lot about them. So this is just an introduction to them. All right, let's talk about basic types. String, number, or boolean. From JavaScript, we have primitive types such as string, number, boolean. In JavaScript, we don't specify the type of a constant or a variable, but we do that in TypeScript. String represents a string value such as hi, what are you, John Doe, etc. Number is a number value such as 56 or 3.14. TypeScript doesn't differentiate between integers and floats. There is also a Boolean data type, which is either true or false. Okay, let's talk about arrays and objects. Arrays and objects are more complex data types. Arrays are defined using the brackets. For example, you can define a constant ARR like this. This is an array, and you define it using the brackets, as I said, and you can define the values inside that array. For example, 1, 2, 3, 4. You can also define arrays that contain string types. For example, directly you can say const weekend, which is an array of type string, and it receives two values, Saturday and Sunday, separated by comma inside apostrophes. Another example is siblings, where you can define an array that receives three values, Mary, John, Claudia, etc. Or the array can be empty altogether. For example, you can declare an empty array at the start of your code, and you anticipate that you will add elements into that array later on. Don't let the keyword const confuse you. Objects and arrays are actually references. They are not direct values. They reference a place in memory that is constant, while the contents inside that place in memory can be changed. But I will be returning to this concept later in this course. So keep that in mind. You can specify the type of the array you are declaring. For example, in this example, I'm specifying that array ARR will be an array of numbers. And when I'm entering the values of that array, I'm entering numbers, because if I enter anything else, there would the TypeScript transpiler will issue me an error, as we will see. Here I'm declaring an array called weekend that is of type string, and I'm entering string values, Saturday, Sunday, etc. Or the array can be accepting Boolean values like this logic. This is the name of the array, and I'm entering three values, true, true, and false. Now, there is an operation called push. If you know a bit of JavaScript, there is an operation that allows you to enter elements into an array. This is the standard method of entering elements into an array. So if you attempt to enter a value of string, of type string, into an array that is of type number, the transpiler will issue you an error, and it will explain to you what is the problem. So here in this example, I'm attempting to enter a value of type string into an array of type number, and the transpiler is telling me that argument of type string, this one, is not assignable to parameter of type number, because I've said that the array ARR is of type number. Now we can talk about objects. Objects are defined using curly braces and a list of comma-separated key value pairs. As in the examples below, I have declared a couple of objects. The first one is named person, and I've opened a curly brace, and I've started entering properties. The first property is called name, and it receives a string value called John. Another property called age, and it is of type number. Another object that I have created is called car, and I've entered a comma-separated key value pairs. For example, the model, this is the name of the property, and the value is whatever you want. Another property is price, and the value is whatever you want of type string. I have declared also an object called dog, and it has one property called name, and the name is Rex, the breed is Pitbull. And I highly encourage you to pause the video and to type this example into your editor yourself and to see what happens. There is a special type in TypeScript called any. Type any is a special type that means you can assign whatever value to a variable or a constant. For example, you can create a variable called entity and say that it is of type any. And then you assign an object to that variable. And that object has one property called value, and that value is of type string, as you can see. Or after that, you can reassign another value to that variable, and that other value is actually another object that has one property called another value, and that another value property is of type string. But if you hover your mouse over the variable entity, VS Code will show you a information pop-up that says that entity is of type any. So you are changing the inside value of the variable entity, but you are not changing the type of entity itself. Then if you attempt to call a method that is named call me, this will not issue a compile time error because you said that entity is of type any. So this is a problem. However, if you attempt to call the method call me on the property another value itself, this will be an error because another value is of type string as you have assigned yourself. So the moral of this story is there is a type called any. This type is problematic. Try not to use it. It is good to know that it is there, but there are other ways to do what you want to do, and I will be explaining those. So just keep this in mind. Type any tells TypeScript to disable any type checking that is relevant to your defined constant or variable, and it assumes that you know what you're doing. Some companies enforce the no implicit any compiler flag. Other companies forbid the use of any altogether. I have been in these companies, so I'm telling you from my own experience. It is preferred to use type unknown instead of type any. As you have probably noticed, when declaring constants or variables using the const, let, or God forbid var, we can specify the type of the value on the left of the name of that variable. For example, const a, and we can say that it is of type number, and after that we can proceed with the initialization and adding the value, assigning the value 5 to the variable a, to the constant a. For example, let some word, and we say that this variable is of type string, and after that we continue with the initialization and we can assign the value of banana to that string variable. TypeScript will infer the type automatically if you don't specify it, but it is better to specify the type for readability, because sometimes if you are working on bigger projects, your team members will actually have better experience reading your code instead of deciphering everything themselves. In JavaScript and TypeScript, you define functions to perform specific jobs, to pass on data from one place to another, and to better structure your code inside your application. Functions can be defined using the function keyword, as I have said previously, or using the arrow function notation. Functions can be also anonymous, for example, that is without declaring a name for that function, and this is specific for callbacks, if you know from TypeScript. Functions can have parameters, as you have seen, and functions can return a value of a certain type. For example, we have defined here one function called do something that receives a value of type string, and it does not return anything. It just prints to the console the value of the parameter value, and this function is declared using the function keyword. Or there is another way to declare a function, which is using the arrow syntax, as you see here. The function do more is actually a reference, a constant reference that is assigned an anonymous function that looks like this. It is receiving one parameter called value of type string, and it returns void, which means nothing. And after that, an arrow, you open the curly braces and you type your statements here. And in this case, we don't return anything. We just output the value of the parameter into the console. In this example, I have declared two more functions. The first function is called add using the keyword function, And this function receives two parameters, a and b, each of them is of type number, and it returns a number. And in this example, I'm returning the sum of these two parameters, which means a plus b. I have defined the function subtract using the arrow notation, and this function receives two parameters also of type number, a and b, and it returns also a number, and in this case it returns a minus b. Okay, so let's talk about object types. Object types are a more complex type in JavaScript and TypeScript. We have already said that. It is defined by listing its properties and their types within curly braces. We have already said that. And any entity that has a property is an object, actually. You don't know this. This is new. So anything that is not a primitive type is actually an object type, including arrays, including objects themselves. For example, let's define an object called school. So I say const some school, which means the reference to this object is a constant, and I define the properties of that object, which means name, it receives a string value, classes, it receives a number value, and students, the number of students, which is also a number value. So I can define after that a function called print school, which takes a parameter called school, and that parameter has the type of this object that you see, which means I'm telling TypeScript that this parameter, which is called school, has the layout structure, the data structure that looks like this. It looks like an object that has a property called name of type string, and another property called classes of type number, and another property called students of type number as well. And after that, I console table that into the output. And then after that, I declare another object called my school. It has exactly the same layout structure as the type of this parameter. It has a property called name, which receives a value main municipal, classes of 10, students 200, and then I call this function print school, and I'm passing the parameter my school into that function. And I highly recommend that you pause the video now and you type in this code into your editor and see what's happening. So in your editor, create a file called main.ts, or you can name it whatever you want. Type in this code, and after you finish typing this code, open a terminal inside your editor and run the command dino run main.ts from your terminal. You should see this output. So what is happening here? When you run the command dino run main.ts, the runtime will read this file main.ts that you have created, and it will go through from top to bottom. So what is going to be happening is that TypeScript will read your source code. It will see, okay, I'm declaring here an object. Okay, I'm declaring a function here. I'm declaring another object here. I'm not executing anything yet because there is nothing to execute until I receive until TypeScript discovers this line of code. This line of code is calling the function. Remember to differentiate. This is a function declaration. This is not a function calling. This is a function calling. So you can declare your function here. TypeScript will not execute this function yet. Okay? This is just declaring the function that it looks like this. Only when you call this function using proper call sign, which means you are calling this function with this type of data, my school, only after that TypeScript will start executing. So what is going to happen then? TypeScript will say, okay, I'm seeing a function that I need to call, which is called print school. It receives a parameter called my school. This parameter should look like this. And what I'm going to do after I receive that parameter, I'm going to output that parameter to the console. this will not going to be executed. This is just informative for TypeScript. It is not going to do anything with it until there is a reason to. But for our example, TypeScript will read this code from top to bottom, and it will start to execute only when it reaches print school. Optional properties. We can specify that some properties are optional by placing a question mark after the name of the property. As you can see in this example, I'm specifying that classes, which is a property of the type of this object type, is optional, and that student is optional as well. Then after that, I'm declaring a object called mySchool, and it has only this one property called name. And this property is required because it doesn't have the question mark after its name. So I can pass this parameter, this mySchool, the object, I can pass it to the function printSchool, and it will be displaying the content of that parameter to the screen. So if you run the code, the instruction dino run main.ts, you will see that there is a difference between the output this time from the previous time. For example, if I go back, you see that I have displayed in the previous example, I have displayed 3 properties, but in this example, I have declared that 2 properties are optional and only 1 property is required. And in this case, I have I have to display only 1 property. Union types are made by combining different types together using the bitwise OR operator from JavaScript. For example, I can declare a function called addPhone, which receives a parameter called phone, and this parameter is of type either number or string, which means either or. So in this case, it can be, for example, some number 4, 5, 6, etc., or a string like this. Okay. As another example, I can define a function called drawPet, for example, and that pet could be either a cat or a dog. This is a theoretical function, but we will see applications further in the course. TypeScript will allow operations that are valid for all members of the union. That is, only common operations. For example, imagine that you have a function called doSomething that receives a value of type either number or string. So you know that the method toExponential exists only on the number type, not on string. So in this case, if you attempt to call the method toExponential on the parameter value, which is of type number or type string, then you will receive an error. And this is directly from my VS Code. It will say that property toExponential doesn't exist on type string or number. It exists only on number. Okay, so you can call only operations that are common to both types. So for example, IntelliSense doesn't suggest toExponential because it's not common to both types. It is only to type number, not to type number and type string. So you can see you have only these these methods. The solution is to narrow the type in code. For example, this is a function called toPower. It receives a parameter called value, and that parameter is of type number or string. And here you test if this value is the type of this parameter value is number. And this is an operator called typeof. This is a built-in operator. So you say typeof value, and it should return you a string result, which corresponds to the name of the type. So if the name of the type is number, then in this case you can call the method that belongs to type number. In this case, toExponential, this is okay. Otherwise, it will be an error. So in this example, otherwise, if I receive something else that is not a number, which means it is string, then I can, for example, simply output the value to the console, or I can use methods that belong to the type string, for example. And I highly encourage you to pause the video and to type this code into your editor and to call it, for example, toPower and enter 6 here, or some string value, for example, and see what will happen. Remember the example previously that we have declared where where the type of the received parameter is something ugly like this. Okay, well, this is ugly, and we can all agree on that. And there is a way to make this look simpler, more beautiful, etc., which is type aliases. Type aliases are defined using the keyword type and the name of the type, and then you assign a value to that type. And in this case, we can declare a type called school, which looks like this. Looks like an object, which is actually the layout of an object, which is a key, a comma separated pairs of key value. In this case, the type school looks like an object that has two properties, name and classes, and the type of the property name is string, and the type of property classes is number, and the type classes is optional because we have the exclamation mark here, the question mark. So this is called, school is called type alias. Now I can declare a function called print school extended because I don't want to redeclare the name of this function, or I can modify this too and change it. But I have declared another function called print school extended that receives a parameter called school, and that the type of that parameter is school with capital letter, which is this. Here is another example. I have declared a type alias called person. That person has three properties. The first property is called name. It is of type string. It has a birth date, which is of type string as well. And there is a property called age, which is of type number. And all these properties are required because there is no question mark after the name of the property. Now, imagine that there is a function declared called add person to database, and that function receives a parameter called employee, and the type of that employee, the parameter, is person, which means any parameter that this function receives must be of type person. So for example, I have defined another type alias called type.3d. So this is the name of the type alias. And that type alias, that type has three properties, x, y, and z. Each are of type number. And I have declared a function called draw. And that function draw receives a point or a variable called point. And the type of that variable is a point3d, which is this. And it does something with that parameter. For example, it calculates the volume, if that makes any sense. Okay, but for the sake of this example, this is how it looks like. This is how you deal with complex types. You define complex types somewhere, and you use them inside your functions. Here are other examples. For example, I declared a function called translate that receives a point of type point3d. There is also a function called rotate that receives also a parameter of type point3d. There is a function called drawLine which receives two parameters. One is called from of type point3d. The other parameter is called to of type point3d. I have also declared another function called createPivot that returns a point3d, and in this case it returns the point of origin. So it returns an object that is of type point3d, and that object has the property x, y, and z, each assigned the value 0. So you see, we are now able to create complex types already using the type keyword, but there is also another way, which is called the interfaces. So interfaces is just another way to name object types using the keyword interface. Like in this example, instead of using the keyword type, we can say just interface. And the difference is we just write down the word interface and the name of that interface. We open curly braces. We define key value or key type value properties, and then we close the curly brace. In this example, I have a point3d that has 3 properties. Each property is of type number, and then I have an interface called person, and that person has couple of many properties, 5 properties: full name of type string, age of type number, address of type string, phone of type string, email of type string. Then I have yet another interface called vehicle, and it has 4 properties. The first one is model of type string, the second one is year, number, should be date probably, or number maybe. Color is of type string, and price of type number. You can also declare functions as properties, as in this example. Suppose you have an interface called point3d, and that interface has 3 properties, x, y, z of type number, but you also want to draw that the point, specific point. So you declare a property called draw that is a function that receives no parameters and returns no return value. And also you can declare another function called move2 that receives 3 parameters, each of type number, and they are required in this case, and it returns nothing. It returns no value. And also you can declare another function, the color of the pixel you want or the point you want to draw, and you can say that it receives a parameter called color of type string, and it returns nothing. So you see, interfaces and types describe the layout of the data structure. They don't describe any specific value. Okay, so you say the interfaces and types just tell TypeScript that any object of this type looks like this, should have this and this structure. Okay. You can extend interfaces as well using the extend keyword. Imagine you were writing an application for a social network. Okay, so you define an interface called person that has the following properties. Now, after you have finished your application, or maybe later on, you decided that you need to start another application that will be for HR for a company, for example, employee management system. So what are you going to do? Are you going to write different interfaces for the same type of data? This is a waste of time, and you can simply take one interface and you can extend it so it can fulfill your requirements for your other application. Okay, so in this case you can say, okay, an employee is a person as well, but the difference is that an employee has couple of fields more that I need to incorporate in order for my application to be correct for the HR department, for example. Okay, while you can continue and write your own social network application without changing the data here. So what you can do is you can say you can declare another interface called employee that extends using the keyword extends the interface person, and you can add the properties that you want. Now you have an interface called employee that is also a person, but it has these properties for more. Now let's go back to the type aliases that we have talked about before. You can join types with a declared type using the ampersand operator. Imagine that you have a type called person that has these properties: name, age, and social security number, for example. Name is of type string, age of type number, and SSN is of type string. But later on in your application, you discovered that you need another type called employee that has in addition to the previous properties, the property called role. For example, an employee can be a manager, can be a developer, can be a lead developer or a project owner, etc., etc. But how would you do that? Would you go and add this property to the previous interface? You might break your code by doing so. So the easy way is to extend the previous type by creating another type called employee, and by joining this type person with the object structure like this. Okay, so this is an object structure that describes a type, and that type has one property of type string. So you can join these, and the result will be a object type that has 4 properties, the first 3 properties plus the 4th one. For example, here you can also extend type employee by, for example, high management, okay, by joining the type employee that you have declared here with the object structure that has 2 properties, bonus of type number and vacation of type number. Okay, so you can extend your software and your data structures like this significantly. There is something called type assertions in TypeScript. You can tell TypeScript what type a variable has if you know it better using the as operator. For example, declare a constant called address input and find that element in the DOM using the address property as an ID. And then when you receive this value, tell TypeScript that this is an HTML input element. This is a built-in type. So you can tell TypeScript that treat this value as HTML input type. You can sometimes avoid the restrictions by removing type information and then recast into another type. For example, you can create, there is a generic type, which is T in this case. We will talk about generics later. And you can say that if you receive a value that you want to treat it as any, so you can treat it as any in this case. So you can remove all type information about that. And after that, you can recast it to be a generic type T, for example. Okay. Let's talk about literal types. If you know the set of values a variable can have, then you can specify it as a type. For example, we can declare a variable called weekend that receives only one of 2 types, either Saturday or Sunday. So weekend can be Saturday, which is okay, but if you attempt to assign the value Monday to weekend, this will be an error. TypeScript will tell you that type Monday is not assignable to type Saturday or Sunday. Okay. The Boolean type itself is a union type of true or false. So this is good if you know the set of values. For example, a weekday is let's say Monday, Tuesday, Thursday, etc. So you can say that the variable can receive only such and such values using the literal types. Like in this example, I have declared a variable called ice cream, and I said that the type of ice cream is either vanilla or chocolate or caramel. So ice cream can receive no other value than one of these 3. So if I say that ice cream is, in this case, is chocolate, then this is okay. If ice cream is caramel, this is okay. But if I attempt to assign another value, strawberry or kiwi or hot dog, okay, then TypeScript will issue me an error, and it will tell me that type kiwi, for example here, is not assignable to type vanilla or chocolate or caramel. Using null and undefined. For uninitialized values of variables, you can use null and undefined. Suppose that you have a variable called a using the let keyword, and you say that the type of a is either string or null or undefined. Now you attempt to console log the value of a to the output, and then after that you assign a value something to this variable a. Then you make a test, and you test if a isn't null or a isn't undefined. If this is the case, then all is okay, and then you can console log the value of variable a. Now you can pause this video and type in the code, and then you can run the program using dino run and the name of your file, and you can see the result. So if you run the previous code, then you will see that the variable a was undefined, like here when you attempt to output the value. So this is undefined before assigning a value, and then it received the value something, and that value was then printed to the console. So if you run the code, dino run main.ts in my example, so you see you output first the value undefined, and only then you output the value something. In TypeScript, you can also declare enums. If you know other programming languages like C#, C++, or maybe Java, then there is a data structure called enums. So an enum is a set of named constants. You can declare enums in JavaScript using, or in TypeScript, using the enum keyword and the name of the enum that you want to use. And then you open a curly brace, and you specify the names of the properties of that enum. So here are some examples. For example, I have declared an enum called RGB, and that enum has 3 properties. Each property, first one is called red, then green, then blue. Enums are such that you can specify the value of each property, but if you don't do that, then the first property starts at 0 by default, and the rest of the properties go incrementally. Like red in this case will be 0, green will be 1, blue will be 2, unless I specify otherwise. For example, this is another enum called logic, and I specify one property called true, and I give it the number 0 by default, and false will be by default 1. Of course, don't use this. This is bad because we have already true and false. True is 1 and false is 0, but this is just an example. I also defined an enum called pet names that has 2 properties, a cat or a dog. You can add other properties if you will. The property cat has the value Mr. Fluff. In this case, I'm specifying the value of the property in contrary to the previous examples. And the value of the property dog is Lord Bowo, which is a string value instead of the numbers that I've used in previous examples. So you can console log the value of the property red of RGB and see what will happen. So let's continue this example. For example, we can create a function called interact, and that function will allow you to interact with your pets. For example, when you come back home from work, you open the door, you enter the house, and you see one of your pets. You don't know which pet it is, but you interact with it. So this function, interact, receives a parameter called pet, and that the type of that parameter is the enum pet names. This is the enum pet names. And then your behavior, your interaction with that pet depends on the type of your pet, right? So you would say to your cat something, but you would say to your dog something else, right? So if you encounter that your pet is a cat, so let's make a test to see if your pet is a cat. So if pet equals pet names dot cat, which means you test that the value of pet equals the property cat. Okay, in this case you tell your cat, okay, Mr. Fluff, your regular bowl of Whiskas. Okay, and your cat then will interact back with you saying something, meow or whatever, or go to hell probably, or I'm going to kill you or something. Okay, otherwise, if it is not a cat, if this pet that you have encountered is not your cat, else, then you will tell your dog, Lord Bowo, it's time for a walk. And your dog will react in a different way, of course. Okay, so here we are creating a pet, and we are creating the value, my pet is going to be a cat, and then we are calling the function interact, and we are passing the parameter my pet to that function. So this is where TypeScript will execute the code first. Okay, so this is an example. So if you run the previous code using the instruction dino run main ts, then you receive Mr. Fluff, your regular bowl of Whiskas, because we've created a pet, my pet, of type cat, which is not a dog, and we passed that parameter to the function interact, which means it tested the pet and it saw that it is a cat really, and it outputted this string. So Mr. Fluff, your regular bowl of Whiskas. I encourage you to pause the video and to type in this code and to see for yourself. Let's talk about type guards. Type guards tell TypeScript how to treat a variable based on its actual type. If a function expects a parameter of type, for example, string or number, and it receives a parameter that is actually a number, then we can place a type guard for that. Imagine that you have a function called do something. It receives a parameter of type either string or number, and it tests then. If the type of the parameter param is number, then you can do something specific to type parameter. The syntax type of and the name of the identifier equals the type name. This is called a type guard. Okay, you can use it a lot of times in your code. There are different type guards, which means checking the return value of the type of operator. String, number, big int, boolean, symbol, undefined, object, function. Type of doesn't return null, however, type of null returns object. You can check that by opening your browser's console and type in type of null, for example. In JavaScript and TypeScript, constructs like if first coerce their conditions to booleans, and only after that they choose their branches depending on whether the result is true or false. For example, 0, not a number, the empty string, 0n, which is the big int version of 0, null and undefined, all coerce to false, while other values coerce to true. You can coerce values to boolean using the boolean function directly, or using the double negation, which is the more common variation, which is preferred because TypeScript infers a narrow literal type true while inferring the first as type boolean. Take a look at this example. Open your browser's console and type each line and press enter. Type first boolean what's up. You will receive true. Type the double exclamation mark operator for the string value doc. You will receive also the value true. So boolean that receives what's up, the type is boolean and the value is true. And the double exclamation mark for the doc, the type is boolean as well and the value is true. TypeScript makes use of logical flow controllers like switch statements and equality operators like the triple equal, for example, the not equal equal, the equal equal and not equal to narrow types. For example, let's create a function called do something that receives two parameters. The first parameter is a of type string or number. The other parameter is b of type string or boolean. And we can narrow the types here and to check if they have the same type or not. So let's say if a is equal to b, triple equal, and this means that a and b have the same types, and this is true only if a is a string and b is a string as well. Okay, because we have the triple equality here. So triple equality checks not only the value but also the type of the operands. So if this is true, that means that a and b can only be of the same type, which is string, and because this is the only common type for a and b, and in that case we can use the methods that are common for type string, which means to uppercase, for example, and we can call it on a and we can call it also on b if you want. Else in this case, if a and b have different types, which means a in this case can be anything, string or number, b can be also anything, string or number. For example, a can be either string or number and b can be boolean, which means this test would fail. Or A can be string and B can be a boolean, and this test will also fail. So this will work only if they have the same type, which means string. So this is a way to test if they what type the parameters have, for example. When declaring a variable and assigning a value to it, TypeScript attempts to determine the type of the variable by looking at the right side of the assignment and then narrowing the left side properly. So here in the code example, I have declared a variable called a, and I'm deciding whether for some condition, if that condition is fulfilled, then I'm assigning a value of type number. Otherwise, I will be assigning another value of type string. So in this example, if I output the value of a, TypeScript already knows that a is either a string or a number. So this is a type, complete type, string or number. Then I assign the value 13 to a, and I output the value of a. TypeScript now already knows that a is now a number. Then I assign a string value to a and output the value of a, and TypeScript tells me that a is a string at this moment. Then I attempt to assign a boolean value to a, and I see here the red mark because the linter, the TypeScript linter, is telling me that there is an error because type boolean is not assignable to type string or number. Okay, let's talk about function type expressions and call signatures. Function type expressions is a way to describe a function. That is, what parameters does the function take, what is the type of those parameters, and what is the return type of the function. So functions of that type can be passed as parameters to other functions. Function call signatures are used when you want, for some reason, to define additional properties of a function using object type syntax. For example, I have declared a type called operation that looks like this. It actually represents all the functions that take two parameters of type number and that return a number. So any operation, any function that takes two parameters of type number and returns a number is of type operation. Then I have declared a function called execute that takes a parameter of type operation, which means that it takes a function as a parameter, and it takes also two parameters of type number x and y. And it returns what? It returns the result of applying the function fn, which is of type operation, on the parameters x and y, on the values of x and y. So I have declared then two functions using the arrow notation. One function I've called add. It takes two parameters, a and b, of type number, and it returns a plus b, and subtraction sub that takes a and b of type number, and it returns a minus b. And since these two functions receive two parameters of type number and they return a number as well, then they are compatible with the type operation. Hence, I can apply the function execute as those two functions, add and sub, being passed as parameters to the function execute, with the values 1 and 2 here in this example, and 12 and 2 in this example. You can run this code yourself. You can type this code into VS Code and then run the command dino run and whatever the name of your file that you have created, and you will receive the values 3 and 10. Here is another example. I have declared a type called other operation, which consists of two properties. The first property is called description of type string, and the other property is actually a function that receives a parameter called data or whatever of type string array, and it returns a string. Then I have declared another function called join, and this function join is of type other operation, so it is a complex type, and it looks like this. It receives a parameter called data of type string array, and it returns a string, and it looks like this. This is the implementation. So the implementation is like this. It is it checks if the parameter that it received data is valid. If it is valid, then it returns the concatenation of the description property of this type plus the join. Join is a built-in operation inside the type array. So it returns the concatenation of the description property plus the content of that array, joined content. Otherwise, if this parameter is not valid, then it returns an empty string. So then I assign the value joining array elements to the description property of join of this. And then I have declared another function called execute other. And this execute other receives a parameter, which is a function, of type other operation of this type. And then I'm passing the value of the array orange, apple, banana as a parameter to this operation function. Remember, function is of type join, and join receives a parameter of type string array. So this is a string array. And then I call the function. I call execute other with join being the parameter. Okay. So if you run this example using dino run and the name of your file, in my case it's scratchpad.ts, then you receive the output joining array elements orange, apple, banana. So now we can talk about construct signatures. You can also use the new keyword to create functions in what TypeScript calls constructors. A constructor creates a new object, and please remember that functions in JavaScript are objects, and then it returns that object with the initialized data inside that object. Alright, so here is an example. For those who don't know anything about object-oriented programming, just keep in mind one thing from this slide, and that is functions in JavaScript and TypeScript are of type object. That's the only thing that you need to remember for now. Those who know any other programming language like C#, C++, or Java will probably understand what's going on here. So I have declared a interface that is called person that has only one property called name of type string, and I have declared a class. And again, for those who don't know what is a class, just wait until we get into classes, and then you can come back to this slide and review it again, and you will be understanding a lot of that. So for those who know what a class is, so I've declared a class called employee that implements person. And in TypeScript, implements mean realization of an interface. So a class is a realization of an interface. In this case, we are implementing the interface. So the class employee has a constructor that receives a parameter called name of type string, and we are saying that this parameter will be a data field in that class. So this class employee will be having a data field called name. And I'm doing nothing with this. I'm just outputting the value of the parameter name with this string, new instance of employee as name. After that, I have declared another interface called person constructor that has only one property, and that property is actually a function, a constructor function. It is using the new keyword to create an instance of type person. Okay, so since employee implements person, then employee is a person as well. So I will be receiving a parameter of type name, of type string that is called name, and I will be returning an instance called person. Then I have created another function called create instance that receives a constructor, and that constructor is of type person constructor of this type. So and it will also receive a parameter called value of type string, and it returns the result of applying the constructor on the value of the parameter value. So using the new, of course, keyword, which means I will be returning an instance of type person. So I have a constant here called SumDuck, and I'm applying the create instance function using the employee as a constructor type and with the value Daffy Duck, and I will be receiving a type person instance here that I can review by outputting to the console log. So if you run this example using Dino run scratchpad.ts, then you will be receiving this string, because this is the first thing that is going to happen. So, and after that you will be receiving, you will be outputting the Daffy Duck value of the property name. Let's talk about generic functions. Sometimes you need to express the relation between the types of input data and output data, or between the types of input data without the need to specify the types themselves. Like, for example, I have declared a function called middle that receives an array of type any, and it returns a value of type any, and it actually returns the middle element of the array. So in this example, I'm console logging the middle of the array that has 10 elements, 1 to 10, and the another array that has string elements, banana, orange, etc. So the problem is that this function returns any, and type any prevents TypeScript from doing any assumptions about the type itself. Hence, we can use generics to describe a generalized or abstract relation between different types while allowing TypeScript to investigate specific type properties when the right moment comes in your program. We use a type parameter in declaration of functions, like in the following example. So here I have redefined the same function middle, but I have added in angle brackets the type t, which is a generic type. It could be anything, but it is a type. And the function, as previously, receives a parameter called array, or ARR, of type an array of t, and it returns either t, an element of type t, or undefined. And the implementation itself remains the same. So you don't have to always write the type specification after a variable, but it is recommended for complex types for readability. The type can be deduced or inferred by TypeScript, and this is called inference. But as I said, it is better for readability for your co-workers in your company, or even for you yourself after a time. If you leave this code and come back to it after, let's say, 1 month or 2, you probably won't be able to just automatically deduce the type that is returned by the function middle. So it's better to specify the return type as well. So I have created 2 arrays. The first array is animals of type string array. The second array is called primes of type number array. The first array has the values dog, fox, cat, duck. And the second array contains the values 2, 3, 5, 7, 11, 13. These are prime numbers. And I'm outputting the type of the middle element in the array, in the first array, and in the second array as well. So in the first array, the type of the middle element will be string, and the second array, the type of middle element will be a number. So if you run this code using the instructions, run scratchpads or whatever your file name is, then you will be receiving string and then number. Here is a more abstract example. For example, I have an interface called salad that has one property called name of type string. And I have created a function called makeSalad that receives 3 generic types, t, u, and v. We don't know these types yet. And it receives 3 parameters, veggie1 of type t, veggie2 of type u, and veggie3 of type v. And it will be returning either a salad or undefined. So this function will either create me a salad, or it will not be able to create a salad, and in that case it will be returning an undefined. So in an actual implementation of this function, I will be checking out the types of veggie1, veggie2, and veggie3, and after that I will be attempting to create a salad based on that. So I will be returning an object that has one property called name, and the value is, for example, tomato salad. Remember, this object that has one property called name of type string is compatible with this interface. Hence, it returns an instance of that interface. What if you want to make constraints on the types that you can use in your generic functions? Sometimes you want to limit the types that your generic function can use. For example, you can say, I want to use only certain categories of types. In this example, I have declared basic interfaces, U, and it doesn't matter what it has inside. That's not the point. So you have a basic interface called U and another basic interface called vehicles. Also, it doesn't matter what is there inside. And I have declared a couple of functions here. The first one is do something, and it receives a generic type called T, and I have a constraint that this type T must extend the type U using the keyword extends. And it receives also two parameters, x of type T and y of type T, but the main constraint here is that T must extend U. Otherwise, this function won't be accepted. Another function here is do more, and it receives a generic type T that must extend the object type that has one property called age of type number. So any object type that has a property called age of type number is compatible, and any generic type that is received by the function do more must extend that type. And of course, there is a parameter of type T. And here is another example, the function repair that receives a type car, and car could be a generic type, and that car must extend the interface vehicles. Okay, so this is a way to create generic functions that accept only certain categories of types, not everything, but a certain categories of types. I will be explaining what are default and optional parameters for a function. One can specify that some function parameters are optional and can be omitted during function calls. A function parameter is specified as optional if a question mark is placed right after its identifier. Like in the example here, I have a function called do something, and it receives a parameter x, but x is marked as optional using the question mark here that comes directly after the name of the parameter. And in this case, I can omit completely the parameter x and do something and call do something without any parameter. Like in this example, if I call do something using the value of 42, this is okay because do something expects a parameter of type number. But I also can say do something without any parameter, which is also okay because I have said that the parameter x is optional. In case of default function parameters, a function parameter can also have a default value that looks like if the parameter was assigned a value on function definition. For example, I have the same function do something, but I have changed the parameter x, and did so I have specified the type of the parameter, which is number, and I have made an assignment of some value. This is telling TypeScript that in case I don't insert any value for the parameter x, the default value will be 42. So if I omit the value of x here, as in this example, the TypeScript will assume that the value of the parameter x is 42. Otherwise, I can specify the value as I've done in the second line. So do something 65. Now I'm giving an explicit value of 65 to the parameter x. If you run this code using dino run and the name of your file, then you will be receiving the value 42 for this line and 65 for the second line. Function overloads. Sometimes we want to execute the same function, but we want it to behave in a different way based on input parameters. Let's say we want to greet people in different ways based on the level of familiarity and if they use a title. For example, if you have a friend called, I don't know, Johnny, then you would greet him like, hi Johnny, how are you, right? But if you encounter your I don't know, your teacher in the university, then you would call him dear professor or sir or something. Okay, so there are different degrees of familiarities that decide the way of greeting. So let's look at this example. For example, I have a naming style, an interface called naming style with a property message of type string, and I have a function called greet. And look at this, I have 4 versions of this function, and each version is different using the parameters it receives, and it has a different implementation. So for example, greet, the first version, receives only one parameter called first name of type string, and it returns a naming style, which means an object of this type. And the second version receives the same parameter, first name, but it also receives an optional parameter, last name. And you see the question mark here, remarking that it is an optional parameter of type string. The return type is the same. And the third version receives also a title, which is an optional of type string, and the implementation of the last version actually corresponds to the third line here. So this is the most generic implementation, okay, and this actually decides how the previous 2 versions are implemented. So in this third implementation, this implementation that corresponds to the third function version, we are actually making a test if the last name, this parameter, which is an optional, if it is not undefined and the title is not undefined, which means this parameter, then that means that we have the third version of our function, and in that case we are returning an object of type naming style that looks like this. The message is hello, and the title, and the first name, and the last name. Okay, and if this case is not true, then we test the other case. If the last name is not undefined, but the title is undefined, which means this is a different way of greeting people, then we return the message, oh, first name, last name, is that you, for example. And in case these 2 cases are not valid, which means we are encountering now a familiar person to you, then we return an object of that says hi and some name, hi Johnny, how was your day? So let's say I'm calling the function greet using the parameters John Smith, and I'm outputting the message to the console. And I have also another version. I'm using greet on Daffy, and I see that I don't have a last name, neither a last name nor a title. And I have also applying the function greet on Albert Einstein, who is a professor. So if you run this code, okay, so the first version is, oh, John Smith, is that you? Because I don't have a title, so I'm using the second version here, okay. And in the second line, since there is no last name and no title, then this is a familiar person to me. So, hi Daffy, how was your day? So I'm using the last version here. Oh, otherwise, when I'm applying the function on Albert Einstein, who is a professor, okay, I know that this is a person that I need to be extra respectful towards him. Okay, so I'm asking, hello, Professor Albert Einstein. Okay. So this is a way to overload your function calls, and to be honest, I have never encountered this way of implementation, and I'm just introducing this for the sake of completeness. Usually you will do your codes using other techniques, but we will come to that. There are other return types for functions, like for example void. Void is a special type meant for functions that don't return a value. For example, you can create a function called getNothing, and you can specify that it returns void, which means it doesn't return any value, and the return statement here is without any value after it, which means you just return from the function without returning any specific value. Type object is a special type for non-primitive types. Anything that is not a string, number, big int, boolean, symbol, or null, or undefined is of type object. This is also different from the empty object type, which is specified using the curly braces, and from the global type object with capital O. Always use type object instead of object with capital O. Type unknown is used to represent a value that can be any. The difference between an unknown and any is that you cannot do anything with unknown, which makes it safer to use. So always use unknown instead of any. Unknown is used when you don't know at development time the type of an object. So it could be probably a string, it could be an object, it could be something else, but you don't know at that time. So instead of using any, which is completely unsafe, you say unknown until you know what is the type. During runtime, for example, when you run your application, you can make other tests inside your code, and you can test your variables. And if you can determine the actual type of your variables at runtime, then you can decide what to do with those variables. But you usually prefer to use unknown to any for safety. Consider this example. I have a function called unsafe that receives a parameter x of type any. It returns nothing. So since x is of type any, then TypeScript doesn't do any type checking. Hence, I can do something like that. I can call the property or the method do something on x. This is okay in JavaScript. This is also okay in TypeScript, but this is bad because it is legal. You shouldn't do that. So I have a safer version, which is another function called safer. It receives a parameter x of type unknown this time. It also returns nothing. So if I attempt to call the method do something on x, then TypeScript will tell me that this is an error because the object is of type unknown. So I can do nothing with it. So I cannot introduce bugs by accident. So this is a safer way to program. If you don't know the type of your parameters or your variables at the development time, then it is safer to denote them as unknown instead of any. There is also one special type called never. The never type is used to indicate that a function doesn't return anything, not even void. This means the function throws an exception or terminates the execution of the application. As an example, I have a function called doSomething that receives a parameter message of type string, and it is said that it returns never. And in this case, it throws an exception, an error. And in this case, when you throw an exception, then you actually jump out from the normal execution flow. So your program will jump into another execution flow outside the function, outside the application, outside everything. Hence, this function doesn't return anything, not even void. So it returns never. REST parameters are used to indicate that a function can take an unbounded number of parameters, and this is achieved using the dot syntax. So for example, here I have a function called doSomething. It receives one parameter called a of type number, and I'm telling TypeScript that you will be receiving an unbounded number of parameters, but I don't know at this moment how many parameters you are going to receive. Just assume that, I'm telling TypeScript, just assume that it is an array of numbers, and that array will be spread using the 3 dots syntax. So TypeScript will behave as if it understands what this means. Another example is the function multiply here. Again, the function multiply is going to receive a parameter called n of type number, And again, it will be receiving an unspecified number of arguments that looks like an array of numbers. So I will be entering these values later, but TypeScript doesn't know at this time, and it allows me to unspecify the number of elements that it's going to receive. So if I go to the example itself, so here at the time of runtime, for example, I know, for example, that I will be using 4 elements as parameters, 4 parameters. So I'm going to enter these parameters that look exactly like if I entered an array of numbers and used the rest operator, this operator, on them. Okay, so it looks like that. So this is the explanation actually of the meaning of this syntax. So if you have a function and you don't know at development time the amount of parameters that this function will receive, this is a way to tell TypeScript that it will be an unspecified number of parameters. Parameter destructuring is a convenient way in TypeScript to extract certain properties directly. Instead of writing the object name dot the property name you want to extract, then you can use parameter destructuring directly. So in this example, I have a function called join. It expects to receive a parameter of type object, and that object has 2 properties, name and surname. So since I know that what type of object I'm going to receive, and I know that that object has certain properties, then I can use the parameter destructuring directly, for example. So I'm going to say join, and you are going to receive a parameter that has the property name, surname, and then you can process the properties the way you like. So here, for example, I have declared a type called person that has exactly 2 properties, name and surname, both of type string. And I'm creating a function called join, which will be receiving an object of type person, as I have indicated here. And I'm directly destructuring the parameter itself, and I'm specifying that I'm going to receive a property called name and another property called surname. And this is a better way to write your code instead of writing join object and then inside your code you will be calling object dot name, object dot surname, etc. So this is a convenient way to write your code. So for example, here you have another example, join, and the name is Daffy, surname is Duck. So pause this video, for example, and type in this code and see for yourself. Then you can run your code using the dino run and the name of your file, and you will receive this result. Now we are going to talk about object types. What are object types, how we can implement them, and how do they look? There are various ways for declaring types. Object types are the way to describe the layout of the data that are passed to and from functions. It's the way to let TypeScript know that what the data looks like in various parts of the application and what to expect when receiving them from other parts. We can declare object types as anonymous as below. For example, a function called print that receives a parameter called person, and that parameter is of type object. And that object has the layout of this. It has one property called name of type string and another property called date of birth of type string. Or preferably, we can declare named types either using the interface keyword or declaring a type alias. For example, I have declared the same type using the interface keyword or using the type keyword. So they look basically the same. Properties in object types can be optional or they can be read-only. Take, for example, the interface line here. It has 2 properties. One is called line type, and it could have one of 3 possible values, dashed, solid, dots. The other property is called color, and it is optional because I have the question mark after the name of the property, and it is of type number. It could have also other properties. Now, suppose I have a function called draw, and it receives a parameter called line of type line, and I want to execute my function in a certain way depending on whether certain properties exist in the parameter itself or not. So in that case, since the property color is optional, that it might be present or it might not. If it is not present, then I test if it is undefined or not. If it is undefined, that means the property color is not present in the parameter, and hence I can, for example, assume that I'm drawing using the black color. So you can decide the way your code will be executing depending on the optionality of the properties in your parameters. On the other hand, properties can be read-only, which means the read-only modifier prevents the programmer from writing to a property, hence avoiding modifying it by accident. Suppose you have the interface CPU, and you have a property called manufacturer, and that manufacturer could be one of three possible companies: AMD, Intel, or ARM. And you have another property called model, and it is of type string, and both properties, manufacturer and model, are labeled as read-only. So you have a function called print that receives a parameter CPU of type capital CPUs, and it outputs the manufacturer to the console. So now if you take that parameter and you attempt to modify the manufacturer and add, for example, Apple, which is also a manufacturer of CPUs, then you will receive an error message from TypeScript saying cannot assign manufacturer because it is a read-only property. If the type of a property is non-primitive, for example, it is an object or an array, then we can still mutate or modify parts of its content, but not the property itself. Remember that non-primitive variables are referred to by reference in JavaScript and TypeScript, which means the name of a non-primitive variable is a place in memory, but the content of that memory can be modified. As an analogy would be a room in a hotel. You cannot change the number of the room, but you can change what's inside the room. So here is an example. I have a type called pizza. It has one property called ingredients, which is read-only, and it is of type string array. And there is a property called pizza name of type string. And I have declared a function, I have defined a function called cook, and it receives a parameter myPizza of type pizza. And what it does is that it prints out to the console the name of the pizza and the ingredients of that pizza using the join operator, join operation on the ingredients array. So I have declared an object called pepperoni, and this is of type pizza. And I have said that the ingredients of this pizza is cheese, tomatoes, and pepperoni as an array of strings. And the pizza name itself is pizza pepperoni. So if I apply the function, if I call the function cook using the parameter pepperoni, this is okay. Now if I take the variable pepperoni, this, and attempt to push mushrooms, for example, to the ingredients, this is also okay, because the reference itself, the place of memory, it doesn't change, it is constant. But the inside, the contents of that reference can be changed, can be mutated. Hence, this operation is okay. So if I say cook again, the same pizza, this will be okay. But if I attempt to change the place of memory, the place in memory, and for example by assigning an empty array of type any, this is of type any, okay, then TypeScript will not allow me that, because now I'm attempting to change the address of the memory, which is not possible in JavaScript. Okay, so it will tell me that I cannot assign to ingredients because it is a read-only property. Those who know how to program in C++ and C understand what's happening here, because I'm attempting to change the address of the memory to something that is not correct. So again, back to the analogy of hotel rooms. You know the number of your hotel room. You can do whatever inside the hotel room, but you cannot change the number itself of the room number itself on the door. Okay, so this is an analogy to that principle. And again, if I run the code using Dino run and the name of your file, in this case scratchpad.ts, so I receive first pizza, which is this line, pizza pepperoni, cheese, tomatoes, pepperoni, and after modifying the ingredients, after adding the mushrooms, okay, then I receive pizza, pepperoni, cheese, tomatoes, pepperoni, and mushrooms at the end, because push puts the new element at the end of the array. Now we are going to talk about index signatures. If we don't know the name of an object property at the moment of design, but we know the type of that property, we can use index signatures. Consider this example. I have a function called getData. I don't know the implementation of that function, so I'm just declaring, I'm telling TypeScript, listen, there is a function called getData. It will be returning an array of strings. Just keep that in mind. I'm telling TypeScript that. So TypeScript will accept this syntax. Then I'm declaring an interface called SumArray, and that SumArray has a property. I don't know what is the name of that property, but I know that it is it is of type string. So that property, this is going to be used as an index. But I know the name of the property, the type of the property itself is string. Okay, so I have declared a variable or a constant reference called myArray that is of type SumArray, and I'm going to assign the output of getData to that. So I have an array of strings that is going to myArray. And I know that SumArray has an index property without knowing the name of that property itself, but I know that it will be returning a string. The type of the elements inside that array is a string. So in this case, I have declared another variable called SumItem, or actually this time this is a constant. So SumItem, and I'm assigning the second item of my array, and I know that this is a string. So this is a way to do complex data transfers. Here is an example. I have a type called person that has one property of type string and another property age of type number. And I have declared an interface called SumStructure that has an index signature. And I know the type of that property is person. So I declare a function called getData that returns me a value of type SumStructure. And I've declared a variable or a reference variable called data that receives a value of type SumStructure. And since SumStructure looks like an array, I can access the second element of that structure. And I know that the second element is of type person. So if you hover the mouse on the element, if you type this code into VS Code and you hover your cursor on the element variable, then the VS Code will tell you that this is of type person. When using string indexers, however, the return type of any other property must match the return type of that string indexer, since object.property is also available as object property inside apostrophes. The solution is to extend the return type of string indexers, as in the following example. So here I have one interface called myType. it has an index signature, index of type string, and the type of the property is supposed to be string. So if I have another property called name of type string and a property age of type number, then this will be an error because I am expected to have a string here. I cannot have a number here because I'm telling TypeScript that if I use indexes here, then the type of the property will be a string. So this is not assignable to type string. So this is an error. What the solution is to tell TypeScript, okay, look, I have a property, an index signature, but the type of the property will be either a string or a number. And in that case, when I say, okay, I have another property called name of type string and a property called age of type number, then this will be okay. This can function. We can extend an interface using the extends keyword. Hence, any variable of the extended type will still have the properties of the original base type, as in the following example. Suppose I have an interface called person that has 3 properties: first name of type string, last name of type string, age of type number. Then I have an interface called employee, and I wanted to extend the interface person. So in the new interface in employee, I will have an additional property called role that will be either one of these values, HR, IT, or management. And I have another property called salary of type number. Then I can declare a variable, a constant object of type employee that has the original properties from person, which means first name, last name, age, and the extended properties of employee, which are the role and salary. We can also extend from multiple interfaces at the same time, which allows us to combine different types together. Take a look at this example. I have an interface called shape. It has 2 properties, x position and y position, both of type number. And I have an interface called color property that has 1 property called color of type string. Now I have an interface called drawable shape that extends both. It extends shape and extends color property. And it has an additional property called outline that is either dashed or solid. So if I create a reference to an object called triangle, and that triangle is of type drawable shape of this type, then it will be having all the properties because it extends 2 interfaces. So I will be having x position, y position that are extended from type shape, and I will be also having the color property that comes from color property, and I will be having also the additional outline property from the drawable shape. Now we are going to talk about intersection types. An intersection type is defined using the ampersand operator. Intersection types is used to combine different types. The intersection type of multiple types will have the properties of all types included in the process of intersection. For example, you have a type called shape, and it has 2 properties, x position, y position of type number, and you have another type called color property. It has 1 property, color of type string. And you create now a quote intersected type drawable shape that looks like this: shape and color property. So when you define, when you declare a variable or a reference, a constant reference to a variable of type drawable shape, it will be having all the properties combined. I don't like the naming of this method, intersection. This is not intersecting. This is actually joining types together, combining types together. But they decided to use the name intersection in the documentation, so I will be sticking to that. But if you want to combine types, this is one way to combine these types. So you have one type and you add the ampersand operator and you use another type, and you can create in this way a combination of both types. Generic object types. Generics are used to create generalized templates for future use cases in situations when we don't know the exact types that we are going to use at the moment of declaration. or when we know that the code is general enough to be used with many types in the future. Take for example the interface container that receives a type parameter, and this type parameter is a generic type that will be specified sometimes later in the code. So container that receives t as a generic parameter, it has one property called layout of unspecified type t. And if we take a look at this example, so interface container t, it receives it has a property called layout of type t, and let's declare a type called flexbox here. It has one property called direction. Direction can be either row or column. And let's declare another type called grid, which has property rows of type number, columns of type number, and an operation, a method called resize, that is a function that receives no parameters, and it returns nothing. So let me declare a variable called my flexbox of type container, and the generic type here will be flexbox, and I can create another variable called myGrid, and again it is of type container, and the generic type parameter will be grid in this example. Generic code promotes usability and allows us to write less code. For example, we can use generic functions instead of writing function overloads. And to be honest, I've never seen anyone writing function overloads. We all use other technologies, other techniques to write reusable code. Using the types in the previous example, let's define a generic function that will make use of them. So I have a function called setContainer. It is a generic function that has a generic type t, and it receives a parameter called layout of type t, and it returns a value of type container of type t. So let's declare a constant container of type container t, and it is an object that has one property called layout. So let's return the container in that case. So I have declared now another constant called myLayout. It is of type flexbox, and the direction it will have as a column. And I'm declaring another variable, another constant called flexbox, and I'm telling to set the container for that flexbox to be my layout. So this is a complex way to declare layouts in your application. I mean, now you understand how generic functions can be very, very useful. Because now the generic function setContainer can be used on any type of layout that you want to define, on flexbox, on grid, or whatever. So this way you write less code and a more general code. TypeScript allows us to write generic code using type aliases as well. For example, here I have the type container that receives a generic type t, which has a layout, the property layout of type t. The difference is that we can describe more than just object types. Type aliases can be used to write helper code. Take for example these helper types. I have declared a type valid or null that receives a generic type t, and it is either t or null. Now I have declared another type called single or array that receives a generic type t, and it is either the type t or an array of t. And I have declared the last one, a single or array or null that receives a generic type t, and it is either valid or null, this applied on a single or array of type t. So if I hover my mouse over the single or array or null, then Visual Studio Code will show me this this message, this box telling me that single or array or null is actually single or array for the generic type t or null. Type array is an example of using generics to describe data structures. Whenever we use string array, number array, etc., we are using the array generic type. Modern JavaScript also provides other generic data structures like map kv. Kv means key value, set t, promise t. There is also read-only array t for arrays that shouldn't change. Please refer to the documentations for more information on these. Now I will explain tuple types. These are array-like types that know exactly how many elements they contain and what are the types of these elements. Take for example this declared type here, string number pair, that looks like an array whose first element should be a string and the other element is of type number. To the type system, string number pair describes arrays, all arrays, whose zeroth index contains a string and whose first index contains a number. So we have an example here. I have created a function called doSomething that receives a parameter called pair of type string number pair. I want to extract the elements of this tuple type, and hence I'm using the index operator, so I'm accessing the zeroth element or the first element using the zeroth index. So for example, I've declared a constant called name that equals pair at the position 0 and another constant called age at the position 1 of the tuple variable pair, and I'm outputting the results to the console, and I'm calling this function for this example array or tuple array that contains the word John and the number 25. So if you run this code using the instructions dino run and your file name, so you will be seeing this output. I highly recommend that you actually pause the video and type in this code and execute it yourself so you can have a feel for it. Please note that tuple types can be destructured using JavaScript's array destructuring. So if I modify the previous code and write it in this way, so instead of accessing each element of the pair array using the index operator, I can simply write the extraction in this way using array destructuring. So it's just an array equals an array, and you can access the elements in that case directly. Again, try it yourself, pause the code and pause the video and write in the code and run it using the instructions and see for yourself. You can also specify that the tuple type is read-only and prevent modifying a variable of that type. For example, if you specify that this type is a read-only pair, then if you pass the same parameter, for example, that as previously to the function doSomething, and you extract the information from that parameter, and then you attempt to modify the zeroth element of that pair, then you will receive an error telling you that you cannot assign to the zeroth position because it is a read-only property. We are going to discuss generics. So in your software development career, you will often encounter a situation where the solution to one problem is very similar, if not identical, to the solution of another problem. You would like to reuse the code that you have once written, so you don't waste time reinventing the wheel. Generics exist in many languages, for example templates in C++ or generics in Java and C#, and in TypeScript as well, to help the programmer in constructing a reusable code. We start using generics in our code by introducing our generic types inside a pair of angle brackets after we declare our function name. Like in this example, I have a function called doSomething, and then I open the angle bracket here and introduce some generic type. And then I close the angle bracket, and after that I continue with the parameter lists and the return type. This tells TypeScript that it will have situations where the function doSomething will have many versions of itself. but each time it will operate on a specific type called some type in this case. We can also use more than one generic type in the input. So here's an example with the two generic types, t and u. I have a function called swap, and it receives two generic types, t and u, and a parameter of type tuple, where the first element of the tuple is of type t and the second is of type u, and it returns a reversed tuple. So in this case it simply reverses the order of the elements in the tuple. So it returns tuple 1 and tuple 0. So if I call the function on the tuple instance with the first element ho as a string and 1 2 3 as a number, then I will be receiving the reverse element 1 2 3 and the string ho. If I do the same thing for another instance of a tuple with an object as a first element, the first element is an object here that has one property called name and the value as Daffy Duck, and the second element is actually a simple string. So if I apply the function swap on that tuple, I will be receiving the first element as quack and the second element as the object with the property name and the value Daffy Duck. Again, you can pause this video and type the code, and then after that run the code using dno run and the name of your file, so you can check for yourself these results. We specify the type of a generic function just like with ordinary functions, with the generic type in angle brackets. So for example, here is a function called identity that is generic. It receives a generic type t inside the angle brackets, and it receives a parameter val of type t, and it returns a t instance of t. So I have declared another function called other identity, and I'm using the arrow notation here. So other identity is of type a generic function that receives a type u and a parameter of type u, and it returns an instance of type u. And then this is the type of the function, and then I'm assigning the reference to the function identity to other identity. Okay, so this is not a function call, this is a reference to a function, because there is no parenthesis here. So this is the name of the function, which means it is a reference to a function. So this is a legal way to name your functions, and writing the generic type as a call signature of an object literal type. For example, you have this variable other identity, and you are telling it that it has a property that is a generic function that has a generic type t, receives a parameter of type t, and returns an instance of type t, and then you are assigning a reference to such a function to this name. Again, this is a type and this is a reference to a function, so you need to distinguish between using a function call and using a function name or a reference to a function. So this is a reference to a function. In this context, we can write generic interfaces as follows. So we have the function swap from previous examples, and I'm declaring a interface called generic swap that is generic. It receives two generic types, t and u, and it has one property that is actually a function, a generic function that receives two generic types, t and u, and it receives a parameter tuple of type tuple, where the first element is t and the second element is of type u, and it returns a reversed tuple. In this case, the first element is u of type u and the second element of type t. So this is a declaration of a function property, and in this case I can declare a variable called mySwap of type generic swap, of this interface, and I can declare that the first generic type is number and the second type is string, and I can assign the function, the reference to the function swap to this variable, because swap is compatible with this property. So since this swap fulfills the requirements of this interface, I can use the reference to that function, the reference to swap, which is its name, and assign it to the variable mySwap. Now we get to discuss generic classes. Generic classes are declared in a similar way to generic interfaces. You declare a class using the class keyword and the name of the class, and you input your generic types into angle brackets like this way. And for example, here we have a property of that class called value, that is of type t, and we have also some other property that is, in this case, a function that receives a parameter of type t and returns an instance of type t. And for this particular example, I have declared a variable called entity, and I have initialized a new instance of this class, awesome class, that receives a generic type. In this case, it is number. So, and then after that, I entered a value 42 to the property value of this entity, of this variable. And in this case, I have declared that the property do something is actually a function using the arrow function notation. And that function receives a parameter called value of type number, and it returns the square of the value plus 2. Just any implementation you can think of. Of course, you can use other types than number with the same class. The most important thing is that whatever you use must make sense to you and to your application. Sometimes we want to pose constraints on the generic type and allow only those types who have at least certain properties. Suppose we have defined an interface that called hasLength, and this interface has a property called length of type number. And then I have declared a generic function called displayLength that accepts generic types, but only those types that extend hasLength, which means supposedly you have an interface called, I don't know, volume, and volume extends hasLength, which means volume has a property called length, but it also has other different properties like probably width and height. Okay, so in that case, volume extends hasLength and it can pass here, but any other volume cannot, any other type cannot pass here, cannot be accepted as a generic type. Please don't confuse the primitive type number with the interface that has a property of type number. These are completely two different things. Okay, so this is an example how you can pose constraints to your generic types. And now we get to the keyof type operator. The keyof operator is used to produce a literal union of an object keys. For example, suppose you have a type called employee that is an object type with properties full name of type string, age of type number, and is student of type boolean. Then the type E, which is a key of employee, is the union of all property names in quotation marks. So the type E here is the same as full name in quotation marks, or age, or is student, all in quotation marks. If the type has a string or number index signature, then keyof will return these types instead. Type, for example, array type, that is an object type with an index signature. In this case, n, that is of type number, and the type of the property is unknown. Remember, whenever you don't know the type of a property or an object, then don't use any, use unknown instead. And we have another type here, array type AT, that is the key of array type, the key of this type. And in this case, this is number. And we have some entity, which is an object type as well, that has a property, index property of type string that returns number. So if I try to get the key of type, the key of some entity, then type E will be in this case either a string or a number. So in this case, because JavaScript keys are always coerced to a string, for example, object 0 is always the same as object of 0 in quotation marks. So the index here is either number or either string. Using type parameters in generic constraints. If you want to declare that a type parameter is constrained by another type parameter, you can do so by declaring the first generic type, that is your main type, and the second to be the key type that contains the keys of the first type. In the next example, I'm going to illustrate a possible use case. So here we have declared a type called fuel type that is a union of 3 different values: diesel, benzene, electric, all string values. And I have declared an interface of vehicles called vehicle that has 3 properties: wheels of type number, fuel of type fuel type, and autopilot that is boolean. So here I have a generic function called getProperty that receives 2 generic types. The first is your main generic type, and the second is to be the keys of the type that you are passing in. So key extends the key of T, which means it's, keyof will return you the union of the property names as types. So here for this example, if you apply keyof on vehicle, then you will receive 3 values: wheels, fuel, and autopilot in this form. So you will receive wheels in quotation marks, or fuel, or autopilot. So this is the result of this example. So in this function, I'm receiving 2 parameters. The first one is val of type T, and the second one is key of type key. So what is going to happen here? This is the key, and I'm going to access the value of that property at the property name key. So in this example, I'm going to declare a variable, or an object, constant reference to an object, which is called model Y, that is of type vehicle. And this object will contain the property wheels to be 4, the property fuel to be electric, and the property autopilot to be true. And now I'm going to print out what are the actual values of these properties. So if I'm calling the function getProperty on the object model Y for the property name wheels, note that the property name itself is in quotation marks, in these 2 apostrophes. So in this case, I'm going to access the value of that property using this JavaScript syntax. Okay, so value, which is model Y, so model Y at the index type wheels. So you go to wheels and see, so you can check, you see that the result is number. And in this case, the specific value is 4. So in this case, if I apply the same function getProperty on model Y for the property fuel, so I will be receiving electric. And if I apply getProperty on model Y for the property name autopilot, I will be receiving true. We can investigate the types of properties of another object. Suppose we have the types, for example here, this is a type called vehicle of object type. And it has many properties: make, that is of type string; price, that is of type number; and available of type boolean. And we have a type called price that is the value of that vehicle type at the property price. So if you go to type vehicle, look for the price property, and the type of price is number. So in this case, the type price equals number. So suppose you have another type called T1, which is of type vehicle, that is the value of that type at either make or price. So let's take it individually. We look for the property make. This is property make. It is of type string, and we look at for property price. Property price is of type number. So in this case, the value, the type value of vehicle at those at this union is actually string or number. So we have also another type called T2, that is the type value of the interface vehicle at the key of vehicle, which means at the union of the properties of vehicle, which means the union make or price or available. So the type union of this is string or number or boolean, right? Because the union, the key of vehicle in this case is make or price or available, all in quotation marks, and the value, type value of vehicle at this union is string or number or boolean. You can use the number type to index an arbitrary type of array elements, as in the following example. Suppose you have a type called vehicle that is an object type with 3 properties: make of type string, price of type number, and available of type boolean. And suppose you have this array, my array, that is of type vehicle array, and it has 2 objects here, maybe more. So if you create a type called E, and that type is the type of my array at the type number, okay? So this syntax means that you will be receiving the type of the array at the property number, and that is actually vehicle. So if you hover with your mouse on E, you will see that type E equals the object type make, price, and available. That is identical to the vehicle type we have declared above. To be honest, I have never seen this technique to be used in any of my projects, but it is here so that you know it can be done like this. Alright, now we are going to talk about conditional types. Conditional types in their basic form are defined in a similar way to JavaScript's ternary operator. Suppose we have the interface person that is empty, we don't care about the implementation, we just need the name. So the interface person, and we have another interface called employee that extends person. Also, we don't care about the implementation at this point. And we have another interface called dog, and we want to create a type called conditional, and that type is conditional in the sense that we check whether employee extends person. If this condition is met, then the type conditional will be string, otherwise it will be dog. So I mean, this example is very abstract in itself, but it shows you that you can create conditional types depending on your use case in your application. Of course, this technique is mostly useful when used together with generic types. So here is an example on using conditional types with generic. Suppose we have the interface person and an interface animal, another interface ID card, and another interface pet badge. These 4 are not related with each other. So we have a type called visitor card, and it is a generic type that receives a generic type parameter t, and we are putting a constraint that t must extend either animal or person. And this type is a conditional type in the sense that if t extends animal, then it will become pet badge, otherwise it will become ID card. And then I create an interface called dog that extends animal. So in this case, I create a type called dog badge, and I pass the type dog to visitor card, and hence I create a badge for my dog. Since dog extends animal, So visitor card will look at T, and it will see that T is a dog, and dog extends animal. And if dog extends animal, which is true, then I will be receiving a pet badge in this case. So now we are going to discuss map types. Map types are another way to create a type from another type. This technique is useful if you don't want to repeat yourself. It is based on index signatures. For example, take a type T and create another type optional, where all of the original properties in T become optional in the type optional. When we then declare an instance of type person and another instance of type optional that receives that is generic and receives person as a generic type, we can see that all properties from person are required, while all properties of optional for person are, well, optional. So here is an example. I have an interface person that has 3 properties: full name of type string, age of type number, and email of type string. And I have another generic type called optional that receives a generic type that is T, and it has one property, and that property is an index property. The requirements of that property is that P must be in the list of properties of the type T, and that this index property is optional, and the type of that property is the same of the type of the property of the original property. So I have created an object called notOptionalDuck that is of type person. This is crucial, it must be of type person. And I have written down only the full name property, and I have assigned some value to that. Doesn't matter which value. The most important thing is that I have only one property of the 3. And TypeScript in this case tells me that I have an error, and that the type that is full name of type string, this object type, is missing the following properties, which is person and email. If I didn't include the type person here as the type of this variable, then this will be okay. But since I've said that this variable must be of type person, then TypeScript will insist that this variable must fulfill the requirements of type person. Then I create another object called OptionalDuck, and it is of type optional that receives a generic type person. Actually, it is a specific type in this case. The optional is generic, but is instantiated with the person type. And it has one property, full name Daffy Duck. This is okay because I've said in the requirements of optional T that T will be optional. So it can be there, it might not be there. And in this case, this is legal code. So this is how you can use optional types and conditional types in your code. On contrary, if you want to remove the optionality from some properties in the original type, you can use the -? specifier as in the example below. So in this example, I have a type called required props that is receiving a generic type T, and it is defined as one property that is receiving a property in the union of all properties of the original type T, and I'm saying -? Which means if this property is optional, that it will become required in this case, and the type of this property is the type of the original property in T. I have another type now called recipe, and recipe has 3 properties: butter of type string, meat of type string, veggies of type string array. And I'm telling TypeScript that meat and veggies are optional. Well, because someone don't like meat, someone don't like veggies, so to each his own. And I have a type called stew recipe that is a required props of the original recipe. So this is a new type that takes recipe, and it removes the optionality of the properties in recipe. In this case, for example, if I declare an object called chicken stew that is of type stew recipe, then I will see that this object will have all its properties as required. So for example, butter, meat, veggies, and if you try to remove meat or veggies, then you will receive an error in this case. Template literal types have the same syntax as template literal strings, but they are used as types. In this example, I have a type called homePet that receives one of three values. It's either cat or dog or bird. I have another type called predator that is one of four values. It's either crocodile or lion or tiger or wolf. Then I have a type called prey that is either antelope, boar or rabbit. And I have a type called animal that is a join of all these types. It's one of the following. It's either homePet or predator or prey. One of the most important features in any object-oriented programming language is the concept of classes. Classes are supported in TypeScript through the class keyword introduced in ECMAScript 2015. The most basic class definition is the empty class, like using the keyword class and then declaring the name of the class and having empty curly braces. Since this isn't very useful, then we are going to add some fields to the class definition. I have another example here, class that is called shape that has a property called type of type string. And this shape can be a circle, triangle, square, etc. Please do not confuse the name of the property type with the type keyword. These are two different things. So you can create an instance of a class using the new keyword followed by the name of the class and parentheses. Depending on your constructor, you can add parameters to the constructor call, but we will discuss this later. So I have declared a variable of type shape called my circle, and I have assigned the value circle to the property type. So fields, when you declare a field in a class, it is usually public by default and writable. So I have a class called point here. It has two properties, x type number, y is of type number. And I'm creating an object of that class using the new keyword. I have the name of the class followed by parentheses. So, and I'm assigning the value 0 to the x field and 0 to the y field. And this is called public access, meaning that you can create an instance of a class and then you can modify the values of the properties of that class from outside. Anything that you do inside these curly braces are inside or private modification. So if I output the values of these properties, I can read them using this dot notation. I can do console log and what is the x value, and I can forward the value of p.x and the value of p.y, and this is called, as I said, public access read from outside. Constructors have similar form to that of functions. You can add parameters, default values, and overload. So for example, for the same class above, class point, that has two properties, x and y, you can add a specific function. This is a very special function called constructor, and it receives two parameters, x and y, and both have default values of 0 in this case. And you can say that the value of this field, this dot x, equals to this parameter, and the value of this field, y, is this dot y equals to the value of this parameter. Constructors have two differences from regular functions. They can't have type parameters. Those belong to the outer declaration. They can't have specific return types. They always return an instance of the class. A class derived can extend a base class using the extends keyword. For example, you have declared the class derived and you say that it extends base. So this is how you create class hierarchies. For those of you who are familiar with hierarchical object hierarchy, class hierarchies. Supercalls. If you have a class hierarchy and you want to access your derived class members, then you need to call the base class constructor first inside your derived class constructor using super. Super is a special function that refers to the constructor of the base class. So here, for example, I have a class called base, and it has one property called greeting, and it has the value of hello from base. I have created another class called derived, and I've said that it extends base, and I've started implementing the constructor. So here I received an error from TypeScript, and it told me that constructors for derived classes must contain a super call, because I don't have any reference to the super call. I'm not using super here. So this is an error. If you use inheritance, if you use subclassing, then you must call super from inside your derived classes. Here in this example, I have a class called base shape, and base shape has 3 properties. 2 of them are data properties, x and y coordinates, and you have a property called draw that is a function or method. We will see methods in the next slide. So you have another class called circle that extends base shape, and it has an additional property called radius that is of type number, and it has an initial value called 0. And I have declared the constructor, and I have declared R to be public. We will discuss the public keyword later. And the value of that parameter R is number. And I have called super here in this line, which is okay, because if I'm going to use anything inside circle, then I have that is extending base shape, then I have first to use super. This is the first thing you do whenever you implement a constructor in a class that extends another class. And then I say that radius equals the value of R. Then I have some implementation for draw, and I output the value of all x, y, and radius. I have declared an object C that is of type circle, and I have initialized a new instance of circle, and I have passed the value of 10 for radius. So if I call now the method draw on C using the dot notation C dot draw, then I will be seeing 0, 0, 10 in my console. Classes can also declare index signatures in the same way as we've shown previously for other object types. For example, we have a class called SomeClass. It has an index signature that receives a property of type string, and it returns either a boolean or a function that is receiving a parameter of type string or number, and it returns a boolean. And I have declared a function property here called getBoolean that receives a parameter s of type either string or number, and it returns the type value of the object this at the property s as boolean. We will discuss this later in this course. We actually extend a class from a base class using the extends keyword, but we implement a class according to an interface. That is, the implements keyword ensures that a class satisfies a particular interface. In this example, I have an interface called shape, and it has one property, drawable, that is ensuring whether the shape is drawable or not. It is a function that checks if the shape is drawable or not. It returns me a boolean. And I have a class called circle that implements type shape using the implements keyword, and it has the same property, drawable, as in shape, and it returns, for example, true in this case, because circle is drawable. I have also a class called rectangle, and I'm telling TypeScript that rectangle implements shape, but I don't include the property drawable inside this implementation of rectangle. I could have other properties here like size, width, or area, etc. But since I don't have the drawable property from the interface shape, then TypeScript will tell me that I have an error. It will say that class rectangle incorrectly implements interface shape and property drawable is missing. So this is how the TypeScript ensures that if you say that a class implements an interface, then that class must satisfy the requirements of that interface. So here is an example of that. Suppose I have an interface called iShape. We usually use the letter I in front of in interface names to indicate that this is an interface, but it is a matter of preference. You can use it or not. It depends how you like that. So the interface iShape has a property called drawable, as we saw before. It is a function that returns a boolean. And I have declared a class called baseShape, and I've told TypeScript that it implements iShape, which means the class baseShape must have the drawable property. So I have the x and y properties of baseShape of type number, and they are initialized to 0 both. And I have the property drawable from the interface iShape, and I've said that this is a function that returns a boolean. And I have another property that is a function. That is a method that is just output into the console some text. And I have a class called circle that extends baseShape, extends this class. And it has an additional property, radius, that is of type number. It has been initialized to 0. And I have also the property drawable from iShape, because it extends baseShape, and baseShape implements iShape, which means that circle must have the drawable property from iShape. And I'm saying that this property will be returning true. And again, I have the method draw. This is overriding the method draw from the baseShape, so your implementation can differ from class to class. In this case, we are outputting some information about the instance of this class. And I have a property called translate that receives 2 parameters, etc. This is not important. The most important thing is that when you implement an interface, you must satisfy the requirements of that interface. And when you extend a class that implements an interface, you also must incorporate the implementation of the requirements of that interface. We can override class methods. Take this example. I have a class called animal that has one method called say. It just outputs the word animal to the console. And I have a class called dog that extends animal, and it overrides the method say in this way. It receives a parameter, something that is optional. It is of type string. And since it is optional, that means it may or may not be defined or valid. So I will test if this parameter is defined. If it is not defined, then I will be calling the original version of say from the base class, from animal. So using the super dot call. So this will be calling the method from animal. And it will return, of course, it will get out of the method. Otherwise, if something is valid, then I will just output to the console bark, 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 because that's what dogs usually do. If I create another class called cat that extends animal, and I use the same implementation here for say, so say receives an optional parameter, something of type string. I also test if something is valid or not. If it is not valid, then I use the original version of say from the class animal. So, and I return out, get out from the function, from the method. Otherwise, if this is valid, then I output to the console log that you forgot to clean my litter box and to fill in my bowl, which actually what cats usually expect from you. In the previous example, it is important that the derived method say preserves the contract from the base class. Changing the optionality of the parameter something in say to become required will result in an error. As you can say, if I remove the question mark here from after the name something, then TypeScript will tell me that say in type cat is not assignable to the same property in base type animal, because this becomes something completely different and say cannot be accepted as a method. Let's talk about member visibility. As in other languages with object-oriented programming support, class members in TypeScript can be accessed based on their declared visibility. By default, members are declared public, which means they are accessible from the outside. You don't have to write the public keyword before the properties. The following example show a class dog that has two properties, a name of type string and a method say. Both are public by default. So here's the class, and we have the property name, which is of type string, and it has the default value rex, and we have the method bark that simply outputs the word bow wow to the console. So if I declare an object d of type dog, and I instantiate d using the new keyword with the class name dog, and I output to the console the name of dog, which is using the dot notation d.name. This is legal code because name is public and accessing public name properties from the outside is allowed. So I can also access the method bark using the notation d.bark, which is also legal because bark is public by default. On the other hand, the keyword protected specifies that the methods and members are visible only to subclasses of the class they were defined in. They can be used for internal processes without allowing the outside or client programmer from accessing them. The following example shows a protected method called API in class app that can be accessed only within the subclass web app, and a protected method retrieve data in web app that can only be accessed only in its own subclasses. So in this example, as I said, we have the class app. It has a constructor and it has a protected method called API that returns void, and this calls, let's say for example that it calls some API or communicates with the backend and retrieves some data. The most important thing is that this method is denoted as protected, which means it is invisible from the outside and only visible to subclasses or within the class itself. So I have another class called web app that extends app, and of course I have a constructor that calls super. Never forget to call super if you have declared a subclass of a class. So otherwise it does nothing. It just outputs to the console some stuff. And I have another protected method called retrieve data that returns void, and this method actually calls call API from the base class. This is legal code because call API is said to be protected, which means it is visible inside the class itself or inside subclasses. And since I'm calling call API inside web app, then this is okay. But if I instantiate an instance app of web app and I attempt to access retrieve data using the dot notation here, then this will be an error, and the TypeScript will tell me that retrieve data is protected and only accessible within the class web app itself, which means here somewhere, and its subclasses. And if I attempt to access call API from the base class app here, then also TypeScript will tell me that call API is protected and only accessible within the class app and its subclasses. Let's talk about private visibility. The keyword private is even stricter than protected. It specifies that the private member cannot be accessed anywhere else, only inside the class it was declared in. Even a derived class cannot access private members of the base class. So we see in this example, I have a class, a app, and app has a private member called credentials of type string, and it has some value. And of course I have a constructor that outputs something to the console. And I have declared another class called web app that extends app, and it has a constructor that calls the super constructor, and it outputs something to the console. And I have a method, retrieve data, that is public. I've written public here intentionally to make you pay attention to that fact. So although this method belongs to web app, it still cannot access credentials from the base class app, because the credentials property is denoted as private, and private can be accessible only inside the class app itself, not from outside. Which means you can even use the public keyword. It doesn't have any effect on private accessibility. What is denoted as private will be visible only inside the class that it was declared in. However, different instances of the same class are allowed to access each other private member data. For example, inside the class app from above, with the private member credentials, the constructor, etc., there is a method called setCredentials that receives a parameter of type app itself, and you can assign the value of the private member credentials from the instance app to the private member credentials of this particular instance. So this is okay. You cannot do anything else with the data that is denoted private, but you can pass the data from one instance to another instance using this way. The keyword private also allows access using bracket notation during type checking. This makes private declared fields potentially easier to access for things like unit tests, with the drawback that these fields are soft private and don't strictly enforce privacy. As a note, in JavaScript, private fields designated with the sharp sign remain private after compilation, which makes them really hard privates. In this example, we have the same example from above, but we are doing something else. We are instantiating an instance of type app using the new keyword, and I'm outputting to the console the value of the app at the credentials property. This is legal. So if I run this code using dino run and the name of your file, in my case main.ts, I will be receiving app from the constructor, and also I will be receiving the word secret, the contents of the private variable credentials. So this is legal, and this is okay. So you have to be careful on what you put in your private data members. Just have this in mind. Static members. Classes can have also the so-called static members. If you know C#, C++, or Java, then you are probably familiar with this concept. These are associated with the class itself, not with the particular instances of the class. Hence, they are shared across all instances of that class. Static members are accessed through the name of the class itself, followed by the dot operator and the name of the static member, as in the following example. So here I have a class called math methods, and it has some static members like library name of type string, and it has some value there. Then there is a method called add that is also declared as static. It receives two parameters of type number, and it returns the sum of those parameters. There is also the method sign that receives a angle parameter of type number. It returns a number, and it returns the sign value of that parameter. The same for cosine. It receives a parameter a of type number. It returns a number which is the cosine of a. So in this case, if I can simply console log the name of the library, which is a static value, as we said, using the dot notation and using the class name instead of a specific instance name. So in this case, we don't need to use the instances. We just use the class name itself, followed by a dot and the name of the static member. For example, here I declare some object or number b in this case, and I use the add static function from math methods using the dot notation, as we said, and we pass like 2 and 3, and we should be receiving 5 here. And for example, here I can use the sign method. For example, you can also type this code in and check for yourself the results. Static members can be public, private, and protected. They can also be inherited. As in this example, I have a class called myClass. It has a private static x, and that has some value. And it has another static method called getMessage that returns some string. If I, from the outside, attempt to access the value of x, then TypeScript will tell me that x is private and only accessible within class myClass. So this is not accessible. And if I create a class called derived that extends my class, and I declare a data member called message of type string, I can use the getMessage method from my class directly using the dot notation followed by derived. It's already inherited, so this is okay. Note that there are special built-in names that you cannot use to name your static members. For example, name and length are not valid names. For example, in this class, I have declared 2 static members, name and length, and TypeScript already is telling me that these names are not valid, and I should not be using them. So name conflicts with built-in property function name, and length conflict with built-in property function length. So don't use these. You can even write static blocks of code inside your classes. If I cite the official TypeScript documentation, they are saying that static blocks allow you to write sequences of statements with their own scope that can access private fields within the containing class. This means that we can write initialization code with all the capabilities of writing statements, no leakage of variables, and full access of our class's internals. So in this example, I have a class called SomeClass with a private member count that is static, and I have some method that returns the value of that field. And I have declared a static block of code that is attempting to do something. It has also a try-catch block, and inside the try block I have some data, like I'm trying to retrieve some data from somewhere, and I am doing something with member data, and I would probably output something. So this is a way to instantiate your class and to make some data transfer between your instances if you want. We have introduced generic classes before, but I'm going to talk about them a little bit here. So the same as with the functions and interfaces, classes can also be generic. We already know that. We attach the type parameters in angle brackets after the class name, and when the class is instantiated using the keyword, the new keyword, its type parameters are inferred the same way as in a function call. Classes can use generic constraints and defaults the same way as interfaces. So here is an example of a generic class. Suppose that we have a class called Flexbox and we don't care about the implementation. So we have another class called Layout that is generic, and it receives a generic type T, and it has a constructor that receives a value of type t, and we assign the value of that parameter to some internal data field called content. Then I declare, for example, a variable called myFlexbox, and I instantiate an instance of layout using the specific type flexbox, and I pass in a new instance of flexbox inside the constructor. So if I, for example, hover my mouse on the content property of my flexbox, then VS Code will tell me that it is a property that is of type flexbox. So let's talk about the keyword this. JavaScript handles this in an unusual way compared to other languages like C++ or C#. In JavaScript, the value of this depends on who is calling the property or the method, which means it depends on the left-hand side. Take a look at the following example. For example, here I have a class called myClass. It has one data member called data. It is of type string, and it is initialized to be empty. And I have a constructor that receives a parameter of type string, and I assign the contents of that parameter to the data member field. And I also I have a method called getData that simply returns the content of data inside this instance, and this instance is referred to using the this keyword. Now I have declared another variable called MC. It is of type myClass, and it is instantiated using the new keyword, and it receives the word myClass, the string literal myClass. And I have also declared an object called obj, and that object has one property called data that is of type string, and it has another property called logger, and it is assigned the value or the reference to the getData method from the MC object, from the MC instance. If I console log the return value of logger, then using dino run main.ts in my example, then I will be getting some data, which is weird. This is not what you have expected. You would expect something like the myClass. So the thing is, that's because the value of this inside the function depends on who called the function, as stated previously. So in our example, getData was called using the object reference, the reference to object, not the reference to MC. So the value of this was object, not MC. If you want to change that, and actually to fix that, then you would change the methods, the notation of the methods inside a class using the arrow function. So if I change getData from, let's check back. So here I have it declared as a normal function notation, and if I change that to the arrow function notation, then this will correctly point to my class, or to the instance MC of my class in this case. So if I output the return value of logger, in this case object.logger, it will return my class indeed. In classes, this also refers dynamically to the type of the current class. Let's define two classes, vehicle and car, where car is a subclass of vehicle. The class vehicle has a method, changeValue, that receives a parameter val of type string, and it returns this. TypeScript infers the correct type from this. Let's take a look at this example. So I have a class called vehicle. It has a property data field called model of type string. It is empty. It has a constructor that receives a parameter of type string, and it assigns the contents of that parameter to the data field model. It also has a method called changeValue that receives a parameter of type string, and it assigns the contents of that parameter to model and it returns this. This is the most important thing here in this example. So I have another class called car that extends vehicle, and it has also a constructor that receives a parameter of type string, and it passes that parameter to the base class, to super. So if I declare an instance car and instantiate it using the new keyword on the class car, and I pass the value Ford to it, then if I declare another instance called my car and I receive the value of change value, passing it Toyota. So if I hover on my second variable, on my second instance, then VS Code will tell me that this is a car. We can specify the type of this in the return type of methods in classes and interface. Meaning here I can say that this change value method will return an instance of car. I simply put vehicle here, or in this case it is vehicle, it's not car. But if I, for example, overridden the method change value inside car, then I would put the return value of change value to be as car. Parameter properties. We can turn constructor parameters directly to class properties. We achieve this by prefixing constructor arguments with one of the visibility modifiers: public, private, protected, or read-only. So in this case, I have a class circle and I have a constructor, and instead of writing inside the circle the properties x, y, and radius, then I simply prefix the modifiers public, for example, public here, read-only, before the name of the parameters, and that will change them to become data members. So in this case, if I declare an instance C of circle and I instantiate it using the new keyword on circle, and I pass the values 10, 20, 30, then I can access x, y, and radius as properties of the instance C or of the class circle, because I have prefixed the modifiers before the name of the parameters. In TypeScript, there is something called class expressions. So I will be citing TypeScript documentations. It says, class expressions are very similar to class declarations. The only real difference is that class expressions don't need a name, though we can refer to them via whatever identifier they ended up bound to. So let's take a look at the following example. So I have an interface called vehicle. It has one property, wheels, of type number, and I have a class called car that implements that interface. It has 3 data fields, wheels, make, model, and it has a constructor that receives a parameter called make and a parameter called model to correspond with the data, respective data fields. And this is the important part, I have declared something called Japanese car, and I have told TypeScript that this is a class expression. So I told TypeScript, look, this is a class. It is a generic class because it receives a generic type T, and it has the following properties. It has one data member called type of type T, and it has also a constructor that receives a parameter of type T, and it passes the contents of this parameter to the data member type. So if I attempt to instantiate an instance called my Toyota using the syntax new and Japanese car, and I pass another instance of car with the make being Toyota and the model being Corolla, for example. If I hover on my Toyota, then I see that my Toyota is actually of type Japanese car, specialized using the car class. Let's talk about abstract classes and members. Classes, methods, and fields can also be abstract in TypeScript. An abstract method or abstract field is one that hasn't had an implementation provided. An abstract class serves as a base class for subclasses which do implement all the abstract members. A class that is not abstract is said to be concrete. And we have an example, we'll take a look at that. So I have an example, I have a class called base and I have declared it to be abstract. It has a method called getName that returns string, but I have declared it also to be abstract. And I have some other method called printName that outputs the string hello and it concatenates the return value of getName. But since getName is abstract and since the class base itself is abstract, then if I attempt to create an instance of base, then TypeScript will tell me that this is not possible because it is an abstract class. So we cannot create instances of abstract classes. Instead, we need to create subclasses of them and provide an implementation to every part that was labeled as abstract. Hence, extending the previous example, if I create a class called derived that extends base, and I provide an implementation to getName, remember getName here was abstract. So if I provide an implementation to getName that returns the word world, then this is possible now to create an instance of derived using the new keyword and the name of the class, and I can call the method printName on D. And remember, printName called getName inside internally. So in this case, this is possible. Usually, abstract classes are used to provide a sort of template that you are going to extend, and only after that you specialize the subclasses and make them more concrete, more specific, and you can use them in your application. The relationship between classes. Classes in TypeScript are compared by their structural layout. Let's take, for example, two classes. The first class called point1 and the second class called point2, and both have the same data members, x and y. So it is possible to declare an instance of point1 and to instantiate it to be of point2. This is because TypeScript acknowledges that the structural layout of each class is identical to the other class. So here I have another example. I have a class called enemy object, and there is a property, a data member called type of type string, and there is a method called act that does something, whatever. And I have another class called npc that has a data member called type of type string as well, and it has a member called act, a method called act that also does something. So if you are, for example, programming a computer game, then you could probably have some structures like this. So both enemy object and npc have the same structural layout, and in this case you can declare an instance e of enemy object but initialize it to be an npc. So this is possible. Let's talk about modules in TypeScript. Any file that contains a top-level import or export is regarded as a module. Otherwise, it's just a script whose contents are available in the global scope. Modules are executed in their own scope, not in the global scope. Hence, the variables, functions, classes, etc. that are declared in a module are not visible outside the module unless they are exported. Following the same logic, all variables, functions, and classes that are exported from a different module cannot be used unless they are imported first. If you have a file that doesn't import or export anything, but you want it to be treated as a module, then add this line to it, export followed by empty curly braces. There are three main things to consider when writing module-based code in TypeScript: syntax, module resolution, and module output target. As for the ES module syntax, a file can declare a main export via the export default keywords. For example, I have a function called SumFunction. It returns a string, and I am telling TypeScript that this is a default export using the export default keywords, and then the name, of course, of what I'm going to export. So here is an example. Suppose you are writing some React application, and in some file called navbar.ts or tsx, if you are writing React components, you have created a component called navbar that is of type react.fc, which is an arrow functional component that returns this thing. It doesn't matter. The most important thing is that this name navbar is exported as default. So in another file, for example in app.ts, you import navbar, this name, directly without curly braces from the name of the file, without providing the extension of the file, because TypeScript will understand that automatically. The difference between default exports and non-default exports is that if you are importing default exports, then you don't need to include curly braces around the name that you are importing. You can export more than one entity. For example, you can export constants, variables, classes, interfaces, etc. simply by using the export keyword without the default. Here, in this example, I'm exporting pi as a constant. I'm exporting the function sign. I'm exporting some class. I'm exporting also some interface. Then in some other file, you can import everything, all those entities, using the import keyword. For example, I have an import keyword, and I have opened the curly braces, and I have included everything that I want to import from the file name. So in this case, I have pi, sign, some class, some interface from the file main. You can even rename your imports using the as keyword. For example, here, pi can be renamed to the Greek symbol p. Please remember that, bear in mind that this symbol is pronounced p, not pi. Also, if you want to rename your some class entity to something else, for example, game class, you can do that using the as keyword. Some interface as layout. So here you will be using layout instead of some interface. So this is a way to make naming more comfortable to you. For example, here const p is equal to the sign of p, etc. You can create a new game class instead of some class. You can also import everything from a module using the star or asterisk wildcard. For example, import asterisk as math from math.js, which means you will import everything and you will rename that to be math. You can, for example, then use that name math to use whatever property that object has. For example, the constant p or whatever functions or methods you have. Like constant as math absolute, if you have a method called absolute defined on the object math, then you can use that and you can pass parameters to that. You can also import a file without including any variable via import and the file name, or like, for example, import vehicles ts. This case, import does not do anything, but the code in vehicles.ts was evaluated, which could trigger some effects in the process. As a side note, please bear in mind that CSS modules are imported in the same way, which means you say import and then the name of the CSS file. And this will make all your CSS styles in that file available to you. Now we get to talk about TypeScript's module resolution. Module resolution is the process of taking a string from the import or require statement and determining what file that string refers to. TypeScript includes two resolution strategies, classic and node. Classic, by default, when the compiler option module is not CommonJS, is included for backward compatibility. The node strategy replicates how Node.js works in CommonJS mode, with additional checks for .ts and d.ts files. Depending on your application, you might want to set or change the module resolution, base URL, paths, root dirs, TypeScript compiler flags. As for TypeScript's module target, for TypeScript's module output options, there are two options that affect the resulting JavaScript output code. Target, which determines which JS features are converted to run in older runtimes and which are left intact. Module, which determines that what code is used for modules to interact with each other. Which target you use is determined by the features available in the JavaScript runtime you expect to run the TypeScript code in. That could be the oldest web browser you support, the lowest version of Node.js you expect to run on, or could come from unique constraints from your runtime, like Electron, for example. And now we come to discuss some utility types that are provided out of the box in TypeScript. TypeScript provides several utility types to facilitate common type transformations. TypeScript utility types are available globally, hence you don't need to import them. There is a list of the most common types that you will encounter frequently. We are going to introduce them here. And if you need more information, always remember to refer to TypeScript documentation for a complete reference. For example, the generic type awaited. If you want to model operations like await in async functions or .then on promises, then you can use the awaited type with the generic type t. For example, here I have a class vehicle that has a constructor and a public data member called wheels. And I have declared a type called v that is actually of type awaited, that receives as a generic type a promise that itself receives a type vehicle. So if I actually hover my mouse on the type v, then VS Code will tell me that v is actually of type vehicle, because this simulates the wrapped type inside a promise. So the same here goes for type n, that is of type awaited, for a promise that receives the type number, and the result is actually type n is number. Same goes for type s, that you do exactly the same, but instead of number you pass in the type string to a promise, which is a specialized form of promise t, and you get in the end type s, which is string. So this is useful in cases you want to simulate your routines and you want to check for the output result. For example, the type partial that receives a generic type t. So given a type t, partial for t will construct a type from t with all the properties of t set to optional. This utility will return a type that represents all subsets of a given type. Let's take a look at this example. I have an interface called GameEntity. It looks like this. It has the following structure. It has a property called type that is one of the three possible values: player, enemy, or NPC. It has a property called hit points that is a number, and it has a coordinate properties for x and y of type number, and there is a property or a method called move that moves that object or that entity by some amount of translation. I have a function called updateEntity that will receive two parameters. So I have two parameters. The first parameter is of type GameEntity of this interface, and the other parameter is of type partial that receives GameEntity as the type, which means this partial will turn all properties of GameEntity into optional parameters, to optional properties. What it is going to do is that it will take the original property, the original GameEntity parameter, it will spread it out, and then it will overwrite these properties here with what has been updated here. Okay? So if I create an object called entity of type GameEntity, and it looks like that, the type is assigned to be a player, the hit point, for example, 100. It has some coordinates, and it has, for example, this property for moving, and I update this entity by calling the function update entity. So I update it with the coordinates x for 10 and y for 20, which means it will leave these two properties, type and hit points and move, as is, but it will update the x and y coordinates. The generic type required T constructs a type consisting of properties of T that are set to be required. It's actually the opposite of partial T. Here, for example, I have an interface called shape. It has three properties, type, x, and y. Type can be one of three values, and it is required. The properties x and y are optional because I have the question mark after the name of the property. And I create an object called circle, and it is of type shape, and I have only the property type to be initialized with some value, because the interface shape allows me to omit x and y, so I don't have x and y here. Then I create another object called shape, small shape, of course, small s, of type required for the interface shape. And since I have filled in only the type property and only x, and I have omitted y here, then I receive an error message from TypeScript that telling me that property y is missing in type, type, circle, x, number, but it is required in required shape. The generic type read-only for T constructs a type with all the properties of T in the new type set to be read-only, which means that the properties of the new type cannot be reassigned. For example, I have an interface called pet here with three properties, type, name, and age, and type is can receive one of three possible values, while name is of type string, age of type number. And I construct an object called myPet that is of type read-only for the interface pet. So I have these three properties initialized. Type is a dog, name is Fido, and age is 3. And if I attempt to reassign reassign a value to the property name for my pet, then I receive an error message telling me that cannot assign to name because it is a read-only type. Here is a very useful type, record for keys and type. This utility type constructs an object type whose property keys are keys and whose property values are type. This utility can be used to map the properties of a type to another type. And I have an example here. This is very, very useful type. I have an interface called person info. It has two properties, attitude and profession. For attitude, it can have one of three values, friendly or mean or grumpy. And profession could be mathematician or lawyer or programmer. And I have another type called friend names. And for example, it could be one of three names, Bob, Alice, Joe. These are the keys. So if I create a database object, so I have an object called database. It is of type record that receives the keys to be friend names, and the type are the person info. So in this case, it looks like this. The first key is Bob. It is taken from friend names. So the first key is Bob, and the profession is mathematician, attitude, friendly, kind of like me. And the other key is Alice. The profession is lawyer, attitude is mean, because all lawyers should be mean if they want to be successful. And the third key is Joe. His profession is a programmer. His attitude is grumpy, because programmers are grumpy. We are all grumpy because things don't work like we want them to. So this is a very useful type that you can use to map one type to another using this technique. Here is another useful type, the generic type pick for T and for keys. It constructs a type by picking the set of properties keys, which could be string literals or a union of string literals from T. and it actually creates a subset. So let's take a look at this interface called pet, which has the set of properties: type, breed, age, name, history, picture. It doesn't matter what kind of types these properties are. Remember the properties themselves. So if I create a type called pet preview, which is a pick for the type pet, and I'm picking these properties: name, age, and picture, then I will be receiving a type that is pet preview. If I hover my mouse over pet preview, then I'll see that pet preview is an object type that has three properties: name, age, and picture. The generic type omit for t and keys constructs a type by picking all properties from t and then removing keys. Keys could be string literals or a union of string literals. It does actually the opposite what pick for t and key does. So for example, if I construct a type called pet short info that omits the following properties: breed, history, and picture, from the original type pet, so breed, history, picture from pet here, breed, history, and picture, then I will be creating a type that has the properties type, age, and name. So type, age, and name. So yeah, so here if I create an object called Tom that is of type pet short info, then I will be receiving an object that has three properties: type, age, and name, because I've omitted these three properties from the original type. Finally, we can talk about the non-nullable type. It receives a generic type called type, or whatever you want to call it. It constructs a type by excluding null and undefined from type. So let's, for example, take the type t0, which is of type non-nullable, and for the generic type t, it receives string or number or undefined, and it excludes undefined from that type. For example, type t1 that is also non-nullable, it receives an array of string or a null or undefined. So if I create a complex interface that has some properties, one of them, the most important thing, is name and description. Name is non-nullable. It receives as a type t, it receives string or null or undefined. And description, the same, it is of type non-nullable. It receives string or null or undefined, which means it excludes null and undefined from that type. If I hover my mouse over the description property, then TypeScript will tell me that it is a property, it is of type string. So it excluded null and undefined from that. So this can be interesting if you are building some databases and you want to exclude some values from your properties. Then you can use the non-nullable here to exclude, for example, empty values or nulls. Well, congratulations, you have finished this crash course on learning TypeScript. Now you have at least basic understanding of how to use TypeScript. And you need to probably start doing something with this instrument, like building projects either on the back end or the front end. You need to read about best practices in TypeScript. I have other tutorials on design patterns using TypeScript, which is a bit more advanced than this tutorial, but you want probably to watch them in the future in order to gain a better understanding of how to program in general and how to program in TypeScript in particular. Also, you need to refer to the official documentations of your tools every now and then, because things change and things change rather quickly. So you need to stay informed. Then again, you need to practice even more, build more projects, and you probably want to get hired and get paid for your wasted time, if I'd say so. And you want to probably show your work to the public so you can get more appreciation being uploaded or even be hired for even more money. Either way, you are just at the beginning of your journey, and I think you have a lot to do in front of you. So yeah, enjoy programming. I mean, programming is a non-stop learning process. If you like this tutorial, please drop a like. If you want, share it. If you have any comments or suggestions, please do write something in the comment sections. And I will see you in the next one.